And we're back. It's time to sort it out. Here we have a projectiles problem where Jumping Joe is going to ride his bicycle off a ramp at a certain angle. It's going to cross the gap, and our goal is to figure out the time in air and the horizontal distance that he travels. So we are given the angle of the ramp and his initial velocity. So launching projectiles at an angle, first start by breaking the initial velocity into components. The initial velocity in the y direction can be found by multiplying the initial velocity times the sine. Similarly, for the x component, it's the cosine. Then let's think about the time to the peak. If Joe is launched with a certain initial velocity in the y direction, his final velocity at the peak of travel will decrease to 0. So at the very top of the path, the y velocity is going to become 0. So how long does it take to do that? If he's near Earth, he's going to accelerate at little g. So this kinematics formula, we plug in what we know, set 0 for the final velocity, rearrange for the time to the peak, and we arrive at this. Then, if he lands at the same height that he launched from, we have a symmetrical path, and the time to the peak is exactly 1/2 of the total time of travel. That means that we can multiply the time to the peak by 2 and proceed to simplify. So if we want to know the total time of travel, we multiply what we found for the time to the peak in this step, and you can substitute in the y component, which we derived above. Then keep in mind the acceleration in the x direction is 0 while he's in the air. That means that he's traveling at constant velocity in the x direction, so we need to find his initial x velocity and then multiply that by the total time. So here's a formula that will do that. Now let's say we wanted to know how far he went. We can combine what we did above. So here, let's plug in for the initial velocity, it's this, and then plug in for the total time, it will be this. Then multiply across the top, and we found a formula for the range. And then using an identity from trig, we can replace this with this, and we get a nice simple formula for the range. This would give you the horizontal distance traveled, however this would not give you the time in the air, so it is important to know all of these steps as well. And that's what you need to turn your screens green.